Hello students, welcome to the second video of algorithm design strategies. In the last video we have already seen what is meant by the algorithm design strategies, and we have started with the first design strategy, divide and conquer. So we have seen that in problem solving, if we will use the good strategy for the algorithm design, we can lead to the efficient solution. So we have started with the divide and conquer, and we have seen that in the divide and conquer, the problem can be divided into the sub-problems, and after that we can combine the solution of these sub-problems to form the solution of the original problem. We have already seen the control abstraction and the computation time, and we have started with what the binary search algorithm. So we have seen how the binary search algorithm is using the divide and conquer strategy and searching the algorithm in the minimum number of the times. So we have, in the last video we have seen one example where we have the successful search. Now we will see one example where we have the unsuccessful search. So for example, if I have the array of suppose 10, 20, so we know that the constraint of this is the array should be what the ascending order or the descending order, depending on the algorithm. Now suppose that this is an array and I have the numbers, 9 numbers. The array index is going to start with the 0 up to what the 8. Now suppose I want to search the number 75. So it is an unsuccessful search. So how this algorithm is going to work in this unsuccessful search example? So the first two steps are reading the array. After that we will initialize the first time our low to the lower bound and our high to the higher bound or upper bound. So our low is equal to what the 0 in the first time, and after that the high is what the 8 for the first time. And as we have seen, the while we have to run until our low is less than equal to high. So right now the low is 0 is less than equal to 8. So this condition is true, it will enter into the while. In the while, it will first step is we have to calculate the mid. The mid is 0 plus 8 divided by 2. So 0 plus 8 divided by 2, the value I will get for the 4 for the mid. So I will first search whether my data is going to lie at the mid location. So at the mid location the data is 50. So this condition is going to false. So it will enter into the next step where we have to compare where the data is less than A of mid or the greater than A of mid. So here my data is 75 is greater than what the A of mid. So my low is going to set to the mid plus 1 and it will discard the first half array. So that time right now my low is right now is what the mid plus 1, that is what the 5, and my high remains what the same. Again I will enter into the while loop. The 5 is greater than equal to 8, condition is true. Again we have to calculate the mid where my mid is 5 and my low is 5 and my high is 8, which is divided by the 2. So 13 divided by the 2, what I am going to get is 6. So my mid is going to be what the 6. So what I will do, I will compare my 75 with what the A of 6. So in the A of 6, the 70 is there, which is again not equal to 75. So I will go to the next step. In the next step, I will compare my A of mid is greater than or the less than data. So my data is 75 is what the greater than A of mid. So that time, so here the low is going to what the mid plus 1. So my high is over here. low is 7. So after this, again I will go into the loop. My 7 is less than equal to high, that is 8. Again I will enter into the loop as 7 is less than equal to 8. So the mid it is going to calculate the new value 7 plus 8 divided by 2. So I will get what the 7. So here right now my low is what the 7, my mid is 7 and my high is what the 8. So again it will enter over here this. The low is equal to high, the mid is calculated, that is what the 7, and it will compare my 75 with the A of mid. So A of mid is what the 80, it will compare that 75 with the 80. This condition false, it will enter over here. My data is what less than A of mid, so my data is what the here 75 and it's less than the A of mid, that is what the 80. So my high is mid minus 1. So my high is 7 minus 1, that is what my high is what right now is what the 6. Again I will enter into the while and I will see that my low is 7 and 7 is less than equal to 6. Here my condition is what the false. I will come out of this while and I will print that the element is not found and I may return minus 1, which will indicate that the location I am not returning the location, so the data is not found, or you can only print the data is not found and you can exit the algorithm. So in this way, this binary search algorithm you have to trace for the successful and the unsuccessful search examples. This is a pseudocode that we have written for what the binary search in the iterative manner. That is what we have to execute the instructions sequentially one by one. In the iterative manner, we have written this particular code. So this is a pseudocode. So it's my request to every student, please execute this particular code. Try to write a program in the C++ or in the Python, whichever the language you are comfortable. So you can try this code in that particular programming language. So take the array element from the user, take the element which you want to search in that particular array, and after that you can print the location where the data is found. If the data is not found, you can simply display the message the data is not found. So this is an iterative algorithm. Now the next thing is we have to see that can we write the recursive algorithm for the binary search? So whenever our problem we are decomposing into the subproblem, and this subproblem are very what you can say refined in terms of the problem which are closer to the simple cases. So that time you can solve the problem with the recursion also. So whenever you are using the divide and conquer algorithm strategy, the best way to implement this algorithm strategy by using the recursion. As in the recursion, one or more simple cases of the problem, we have the straightforward solution. So for example, I have the factorial number, factorial function. So in the factorial function, so this is my fact function which is taking one argument called as n. So whenever I am saying that my n is what the equal to 0, I am returning what the 1, or my answer is what the 1. Okay, so my answer is what the 1. Else means my n is not 0, I am saying that my answer is n multiplied by fact of n minus 1. Fact of n minus 1. So what we are doing over here is, in this factorial program, what we are doing, we are first checking if n is equal to 1 or n is equal to 0, we are setting the answer is equal to 1. Otherwise, answer is nothing but what n multiplied by factorial of n minus 1, and after that we are returning what the answer from this factorial function. Means in the recursion, one or more simple cases of the problem have the straightforward solution. So for example, whenever n is 0 or 1, my answer is 1. These are the straightforward solutions. In other cases, now what we are doing is we are redefining the problem in the terms of what the problem that are closer to the simple cases. So here my problem, here my n multiplied by fact of n minus 1. So in this way we are redefining the problem in terms of what the problem which are closer to the simple cases. Now see the example of the finding the factorial 3. So we will call the function with the fact of 3. At that time n is equal to 3. So in my control stack I have the first activation record for the function fact of 3, where n is equal to 3. The fact of 3, it will call 3 multiplied, or the line at which 3 multiplied by fact of 2. So the fact of 2 is my current active function. So the activation record of the fact of 2 is going to be pushed into the activation stack. Again the fact of 2 is going to push the activation record of what the fact of 1. Same way, the fact of 1 is going to be what the push activation record of what the fact of 0. So when the fact of 0 is there, the value of what the n is 0, the answer is 1, and after that it will execute the statement return answer 1. So the answer 1 is going to be the 1 value is going to return to the caller. The caller of the fact of 0 is fact of 1. So at this line, the statement again start execution in the fact of 1. So my n is 1 and the fact of 0 is again returning what the 1. So answer is 1, and the next line it will execute return 1. 1 multiplied by 1, answer is 1, so it will return 1. So the return 1 is going to be returned to its caller. So the fact of 1 caller is fact of 2. So in the fact of 2, the line was what's executing this line again. So where my n is equal to 2 and fact of 1, I am getting what the 1. So 2 multiplied by 1, answer is what the 2, and it will return the value 2 to its caller. So the fact of 2 will return the 2 to its caller. So fact of 3, where my line was executing again the same. Here my n was 3, and after that the fact of 2 is returning me what the 2. So 3 multiplied by 2, the answer is 6. So it will return what the 6. So fact of 3, suppose main is calling fact of 3. So I will get the 6 as the return value from the fact of 3. In the same way, the factorial, in the same line, the binary search is going to work with the recursion. So for example, I have the array with what the 10, 20, 30, 40, 50 at the indices 0 to 4. So initially I will call my binary search function with value 0, low value 0, and my high value is 4. So it is my current activation function. It will go in the body and it will see that my low is equal to high. This case is going to false, so I will enter into the else loop. In the else loop, the first step is we have to calculate the mid. So mid is low plus high. So 0 plus 4 divided by 2. So the mid is going to be what the 2 over here. So the mid is what the 2, and it will what the see whether my data is present at A of mid. So A of mid is what the 30. Suppose I want to search 40. So it is not equal to data. So I will enter into the else part. So in the else I will see that X, the data is what the 40 is less than A of mid. But 40 is greater than A of mid. So I will execute this line. So in this line again my binary 0 of 4 will call the same function recursively with value what the b, and my mid plus what the 1 is what the 3 and what the high is what the 4. So it will call the binary function 3, 4. So again when I will call this, so low is not equal to high in this case, so it will enter into the else loop where it will calculate the mid again. Here the mid is what the 3, so here the mid is 3, so it will see that my data, that is what the 40, is equal to A of mid. Yes, it is equal to A of mid, so it will return the value of the mid, that is what the 3, to its caller. So B of 3 of 4 is going to return the value of mid 3 to its caller. Caller is B, binary search 0 of 4. So that is my last statement. So 3 is again going to return by what the binary search 4, 0 function. And suppose the main is calling this binary search function. So I will get the return value as 3, which is nothing but what the location of what the element found at the location 3. Suppose the data is not found, so that time my binary search function is going to return the -1. So in this case, we can also write the recursive function for the binary search. So you can use the iterative or the recursive, whatever the manner you want. Now the next thing that we have to see that how we can find the complexity of the binary search algorithm. So what we have seen that in the binary search, in every step, the search area we are dividing or reducing by the half. So here we have seen after calculating the mid, depending on the value which we want to search, we are discarding the first half or the second half. In the first half also, again calculating the mid, again we are dividing the array into the two parts, again depending on that element which we want to search, we are discarding one of that part. So in this way, in every step, the search area is what the reduced to half. In the best case, the element is going to present at the mid, so we required only one comparison, so that is nothing but what the big O of 1. So this is my best case scenario. In the worst case, suppose the element is not found, so how many comparisons we have to do in this particular case? So what we will do in the first, suppose my element is from what the 0 to 9, so we will divide the array into what the, in the two parts, and what we will do in every step, what we are doing is we are dividing the search area into or reducing the search area by the half. So after the second bisection, again my search area I am dividing into the n by 4 elements. So in this way, when I will do the ith bisection, so that time the number of the elements in my list is become what the 1. So how I will write this? My n element I will do what the 2 raised to what the k, that is what the kth bisection. At that time my array list is consist of what the 1. So that time what I will do, n is equal to what the 2 of k. So that is the element. So n is equal to 2 of k. So k is number of the time we are going to divide the array. So if we will take the log on the both cases, so log of n is equal to what the log of 2 of 2 and k. So I will write that k what the multiplied by log of 2 of 2, and this value is becomes what the 1. So here my k is nothing but what the number of the comparisons that I am doing, and it is nothing but what the log of 2 of n. So my worst case complexity is what the big O of log of 2 of n. So in this way, log of n to the base 2. So in this way, we can find out the complexity of the binary search algorithm in the worst case. So this is the quiz. So in this search algorithm, we are going to begin at one end, and we will scan the list until the desired atom is found or end of the list is reached. So what will be the answer, students? So it's a linear search where we are comparing element one by one until we will found the element or we will reach to the end of the list. To implement dash search algorithm, the list is going to be sorted. So in the binary search, the criteria is constraint is that list should be sorted. So this is all about algorithm strategy, that is divide and conquer, with the example binary search algorithm. Thank you, student. For any query, please write down to my mail psvidup@pict.edu.